Hello, this is Dr. Mears, and today we are going to learn about pyramids, cones, and spheres. Pyramids. The base of a pyramid is a polygon, and the three or more triangular faces of the pyramid meet at a point known as the apex. In a right-angled pyramid, the apex is directly above the center of the base. So here's a square pyramid. We have the reason why it's a square base pyramid is because the base or the bottom part is a square. You notice that the height is attached to the apex right here. Remember, height and base meet at a 90-degree angle. We also have the slant height, and the slant height is right here. That's the height of the slant. And here are your triangular faces. We have a tetrahedron where the base is a triangle, as we see here. And we have a hexagonal base pyramid in which the base here is a hexagon. Cones. Pyramids and cones are very similar. The base of a cone is a circle. It will not have any triangular faces. So remember, when we were building them, for the students that have me this year, we were building them, these were not triangle faces. This is the vertex. That's the tippity top point. Just like this was the apex, this is the vertex. The vertex point is directly above the base, which represents the height, which also meets at a 90-degree angle to that circular base. Here's the radius. The radius is halfway through our cone, so that's the radius measurement. And we also have a slant height, the height of the slant. Okay, and one that we know well are going to be spheres. A sphere is defined as a set of all points in three-dimensional space that are equidistant from a central point. Half of a sphere is called a hemisphere. So here we have a sphere. Again, we're going to be needing the radius. That's where you find the radius. Hemisphere. Again, there is the radius. Let's do some examples. So what are we going to be doing with all of these shapes? We are going to be finding surface area and volume. What are surface area and volume? Surface area is the area of the outside of the shape. Add up all the areas of each side or each face. So it's the outside, as if we wrapped it in wrapping paper. All right, how about volume? Volume is the amount of space occupied inside the shape. Let's say that we had a cone, such as this, and we wanted to fill the cone up with water or ice cream. How much space would it actually take up inside? Okay, so here are our formulas. We have pyramid, cone, and sphere, surface area, and volume, and that's what we're going to be doing today. Let's just look at the actual formulas. For surface area of a pyramid, it's x squared plus 2x times L. Now, the x is the length of the sides of the base, of that square base. L is going to represent our slant height. Volume is 1/3 times the area of the base times the height. And remember, area of the base, that's going to be your length times your width. A cone, pi for our surface area is pi r squared plus pi r L. R is the radius, L is the slant height. I just want you to know that this right here, that's actually the area of the base. Our volume, 1/3 pi r squared h. Radius for r, height is h. And again, notice this right here, pi r squared h, that's the area of the base. And in a sphere, we have 4 times pi r squared. Ooh, we're taking 4 times the area of a circle. And for volume, it's 4/3 pi r cubed. Now, when we're writing these out, remember, you're going to have to remember units. And when we talk about surface area, our units are going to be squared. When we talk about volume, our units are going to be cubed. And in surface area, remember, it's just the outside. So we're just dealing in 2 dimensions. So that's why it's squared. Once we bring in volume, we're bringing in the inside. We're bringing in another dimension, which is why it's cubed. So here we're working in 2, here we're working in 3. Okay, let's try some of these. So first, for our note. The problem might actually ask you for a curved surface area of the cone. So if we look here, all that I would be talking about is this cone part. It's as if we cut this base out and we just threw it away. So that's what the curved surface area of a cone is. Oops, I don't like how I wrote that line right through it. So it's as if we had no circular base. And that's just pi times r times L. And so sometimes the problem would ask you. So let's see what we have to do. Number 1, find the curved surface area, find the total surface area, and the volume of the cone. All right, curved surface area. So we know curved surface area is going to equal pi times r times the slant height. Okay, so we could use pi in our calculator. I'll show you what that is. Times, now if we label this, we're going to label that as radius. Remember, this is L, or slant height. And then this is actual height. Because remember, height and our base are going to be perpendicular to each other. So that's how you actually find the height. Okay, so pi times r is 3 times L is 5. And some people might actually like to list these as R equals 3, L equals 5, H equals 4. You might like doing that just another way if you wanted to. Now in your calculator, you're going to turn it on, and I want you to notice this little pi button right above your exponent button here. Your little caret is the pi button. It's blue, so in order to get to the blue buttons, remember we have to push the blue button to get to the blue button. Okay, let's multiply times 3 times 5. You could use 3.14, that is fine, but I wanted to use my pi button. I'm going to be rounding to 3 significant figures, so this would be 47.1. So this equals 47.1 centimeters squared because it is an area. Okay, what's next? Total surface area. All right, so total surface area is going to be, let's go back up. Here's our cone. That's going to equal pi r squared plus pi r L. Perfect, okay. So we have all these. Pi times r squared, so r is 3 squared, plus pi times r times L. Now, any way that you want to do this is fine, because you do have the 47.1, so that is this one. I want you to notice these two are the same. So you could put it in if you wanted to. I'm just going to do it all in one step in the calculator. It's actually more exact when you do that because you're working with the 2 pi's here. So let's just do pi times 3 squared plus pi times 3 times 5. So I like doing it all in one line, and then I double check just to make sure. Perfect, enter. And I'm going to round 75.4 because this 9 is going to bring us up. So 75.4. We're dealing with area, so centimeters squared. Okay, sweet. All right, let's find volume. All right, volume is V equals 1/3 pi r squared h, and I just wrote that down right here so that we have it. Okay, so let's just substitute our numbers. I'm going to put a little parentheses around the 1/3. Pi r squared, so that's 3 squared. And now our height. Be careful, our height is 4. So they're asking for how tall this shape is, not what the length of the side is, the slant, okay? So just be careful. And again, we can put it into our calculator just as we see it. Parentheses 1/3 times pi times 3 squared times 4. All those parentheses. I gave everybody a parentheses, like they big old hugs today. And I put it in correctly, yes. Again, 37.7 because the next to the 6 is a 9, so I'm going to round that up to 37.7 centimeters cubed, okay? Because you're bringing in that other dimension. Now we're filling the shape up. We're not just looking at the outside. We're looking at the inside. Okay, so we have, here we go, those 3. Let's go on to the next example and see what they want us to find there. Number 2, find the volume and surface area of the pyramid. Okay, let's write down our volume of a pyramid formula first. So volume of a pyramid is 1/3 base area times height. So let's write that down. 1/3 base area times height. And I'm actually just going to go halfway down the page here because they want us to find surface area. So I want to leave myself some room, and I'm going to do surface area. And surface area, if we look on our little chart, pyramid, surface area, x squared plus 2xl, x squared plus 2xl, where x is your base base length. And remember, L is slant height. Okay, so first let's find the volume. So we have to do a couple things here. We have the 1/3, that's cool, all right. But we need to find the base area. And so the base area, we look, it's the shaded region. And so the base area is going to be our side length 5 times our side length 5. And I'm actually going to write it in parentheses. I don't like using the little x. Okay, so our base area is going to represent 25 centimeters squared. I'm just going to use the 25. So in filling this in, I'm going to get 1/3 times 25 here times, now I need our height. Okay, so let's see what they give us. Here, they give us our base lengths, and they also give us our slant height. So this dotted line is our slant height. I know it meets at a 90-degree angle, but it is not the actual height. The actual height is how tall this is from the middle of the base all the way up to the apex here, all the way up to that tippity top point. So we actually need to find this side. This is the height. So we need to find this here. I'm hoping that you're seeing that we're probably going to have to use the Pythagorean Theorem. And you're going to say, but Dr. Mears, what is the length of that side right there? Because we're missing two. We're missing the height and we're missing that bottom side. Well, I'm here to tell you, because this is a square base, okay, if you notice, this line is going to the middle of the square. If this whole side is 5, then what do you think half of it will be? If the entire side is 5 and we only need half of it, it's going to be 2.5 centimeters. So that little line right there is 2.5 centimeters because this whole entire line was 5, half of it is 2.5. So let's just pull out the actual triangle. So here's the height, here's the slant, here's the base. I hope you're seeing that. We're going to be doing an ABC situation, or ABC or ACH, I guess. So we are going to be using the Pythagorean Theorem. So be careful. The one that matters is the C. Okay, so if you're labeling sides and you're like, I don't know what A and B are, it's okay. It's fine. I didn't even have to write these, everyone. I could have just erased these. The one that matters is C, because C is on its side by itself. A and B can be flipped around. It's fine. You're going to square them. It's fine. So I could put down whichever one, but I just have to make sure that the 2.5 is squared, and I'm going to square my h. So I'm really just going to use my h because that's what we're looking for. Okay, these could be flipped. It's okay. As long as the 13, it's the longest side, it's the hypotenuse, and the longest side is always across from this 90-degree angle. I guess that 90-degree angle is pretty important, huh? Okay, so let's do let's turn our calculator on. Here we go. All right, 2.5 squared is 6.25. So 6.25 plus h squared equals 13 squared is 169. Let's bring over the 6.25. I do like showing you all of my steps. Let's line it up correctly, even though the calculator is 6.25. Okay. H squared equals 169 minus 6.25. 162.75. 162.75. I'm not done yet. This is squared. I don't want it squared. I want it unsquared. I just want 1. I don't want 2. So take the square root, and our height, square root, 162.75. Enter. 12, I'm just going to round, 12.8 because this 5 is 5 or greater, so it's going to round that to an 8. So our height is 12.8 centimeters. So this is 12.8 centimeters. 12.8 centimeters. So I'm going to go over here, 12.8 centimeters. So here, 12.8 centimeters. I found the height. And where am I going to put it? 12.8. So now I'm ready to rock and roll to find my volume. So the first thing that I had to do was I had to find my base. Then I had to find my height. And third, now I'm actually able to find my volume. So finally, let's put it in our calculator. 1 divided by 3 times 25 times 12.8. And I get 106 and I'm just going to, that's 106.7. I feel like I'm rounding a lot here. If you want to wait to round, whoops, 0.7, that's absolutely fine. For IB questions like this, what they're looking for is the work, and sometimes they actually have a range. They may say, okay, accept answers between 106.5 and 106.8. So sometimes they do that because they know a lot of rounding is involved. Doing that to that one decimal, since I started with 3 significant figures here, and that went to that one decimal. There's my lights. It's a way to go. But they're looking for, what they're looking for is your formulas. They're looking for your substitution, and then finally the answer. So they will give you partial credit on problems like this. Okay, so that's our volume. And notice centimeters cubed. Let's find our surface area. Surface area, x is the base length, so we see that it's 5. So this is going to equal 5 squared plus 2 times 5 times our slant height. Our slant height, 13, you got it. So this was x equaled 5 and L equaled 13. This is a little bit easier, huh? And then let's just put it into the calculator, clear. So we have 5 squared plus 2 times 5 times 13. Beautiful. And we get 155. And that's centimeters squared. And that's our surface area. That's the outside. That's the inside of our beautiful pyramid. Okay, this has been Dr. Mears. Pyramids, cones. We didn't do a sphere example, but you do need the radius for sphere, and that's it. So I'm hoping that you could locate which formula you needed for volume or surface area and then substitute it in. So I didn't do one of those. Okay, hope this helped. See you soon.